Hello students. You're welcome to today's chemistry lesson. We'll be studying gas laws part 1. But before we continue, let's recap what we studied in our last lesson. In our previous class, we explained the states of matter. We learned that matter exists in 3 common states: solid, liquid, and gas. Examples of solids include stone and ice. Examples of liquids include water and oil. Examples of gases include air in a balloon. Each state of matter behaves differently because of the arrangement and movement of its particles. We also discussed the kinetic theory of matter. The word kinetic means movement. It is applicable in processes such as melting, solid to liquid; freezing, liquid to solid; boiling, liquid to gas at high temperature; evaporation, liquid to gas at any temperature; diffusion, movement of particles from high concentration to low concentration; osmosis, movement of water molecules through a semi-permeable membrane from high water concentration to low water concentration. These processes occur because of the movement and energy of particles. Our lesson objective for today is to learn about Boyle's law and Charles' law. Back in 1662, a scientist named Robert Boyle discovered something interesting about gases: how their pressure and volume are connected, especially when the temperature remains constant. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure, provided the temperature stays constant. In simple terms, when pressure increases, volume decreases. And when pressure decreases, volume increases. This relationship can be written mathematically as P times V equals K, constant. For 2 different conditions, the formula becomes P1 times V1 equals P2 times V2, where P1 is the initial pressure of the gas, V1 is the initial volume of the gas, P2 is the final pressure after the change, V2 is the final volume after the change, and K is the constant value. Let's break this down step by step. Now, let's look at a quick example. A gas has an initial pressure of 820 mm of mercury and a volume of 260 cubic centimeters. If the pressure changes to 410 mm of mercury, what will be the new volume? Using Boyle's law, P1 times V1 equals P2 times V2. To find the new volume, we rearrange the formula. V2 equals P1 times V1 divided by P2. Now, substituting the values. V2 equals 820 multiplied by 260 or divided by 410. V2 equals 520 cubic centimeters. Let's connect this to real life with a bicycle pump. When you push down the handle, the air inside is compressed. This reduces the volume and increases the pressure. The increased pressure forces air into the tire. This is Boyle's law in action: decreasing volume leads to increasing pressure. Charles' law helps us understand why gases expand when heated and shrink when cooled. Charles' law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature, measured in Kelvin, provided the pressure remains constant. This means when temperature increases, volume increases. When temperature decreases, volume decreases. It is important to note that temperature must always be converted from degrees Celsius to Kelvin before solving gas law problems. To convert Celsius to Kelvin, Kelvin equals degrees Celsius plus 273. Absolute zero is minus 273 degrees Celsius. This is the lowest possible temperature. Mathematical expression. Charles' law says Volume is directly proportional to temperature. This means volume divided by temperature equals K, constant. For two different conditions, initial volume divided by initial temperature equals final volume divided by final temperature, where V1 means initial volume, T1 means initial temperature in Kelvin, V2 means final volume, T2 means final temperature in Kelvin. You got this. You're doing great so far. Let's solve an example. A gas occupies 200 cubic centimeters at 27 degrees Celsius. What will be its new volume when the temperature is increased to 87 degrees Celsius, assuming the pressure remains constant? Solution. Convert to Kelvin. Initial temperature equals 27 degrees Celsius plus 273 equals 300 Kelvin. Final temperature equals 87 degrees Celsius plus 273 equals 360 Kelvin. Apply Charles's law. Final volume equals initial volume multiplied by final temperature divided by initial temperature. So, final volume equals 200 multiplied by 360 divided by 300. First multiply. 200 times 360 equals 72,000. Then divide. 72,000 divided by 300 equals 240. Final answer. The new volume of the gas is 240 cubic centimeters. Real-life application of Charles's law. Hot air balloon. When the air inside a hot air balloon is heated, its temperature increases. According to Charles's law, when temperature increases, volume increases. The air expands, becomes lighter, less dense, and the balloon rises. When the air cools, the volume decreases, the air becomes heavier, and the balloon comes down. You have completed this lesson. Congratulations! Let's go through a few quick questions to help us review what we've learned so far. In today's lesson, we explored Boyle's law and Charles' law. I hope you found the lesson engaging and easy to understand. In our next class, we will continue with gas laws, part 2. Thank you.